In the video about the regression model, we described regression as the model of a continuous relationship between x and y. But then in the video that introduces correlation versus causality, we said that we can use regression also as a tool to estimate the effect of a discrete change in x on y. The beta coefficients do have a different interpretation when we use a discrete independent variable. So let's plot some data to illustrate this. The discrete version of x can be either 0 or 1. That's a firm investing in R&D or not investing in R&D. If you plot this, you will get different levels of the outcome y. And all these data points will be bunched at two discrete points on the x-axis at 0 and 1. When we use an OLS model to estimate a straight line, we are essentially connecting the average of the data points at x equal to 0 with the average of the data points at x equal to 1. Once you see this, it becomes easy to interpret the parameters of the OLS model. Beta 0 will be just the average of all the data points at 0, that is μ0. μ1 is the average of all the data points at x equal to 1. The slope parameter, beta 1, is just the difference between these two averages, so μ1 minus μ0. While a comparison of means can only work for a limited number of discrete changes, regression can also be used to estimate the instantaneous rate of change. Therefore, we can say by how much y changes when x changes by 1 unit. So it turns out that this is simply the derivative of y with respect to x, meaning that del y over del x is equal to del beta 0 plus beta 1 times x plus u over del x is equal to beta 1. And there you have it. That's the interpretation of a regression with a continuous independent variable from which we started in the previous video.